Now the other thing that moldic fossils give us, that fossils preserved in the normal fashion don't, is we get to see not only the outside but also the inside. Now I just recently had a French colleague come over and visit me, a guy named Patron or something. What fascinated him was when we brought him to the museum, he wanted to look at Enoplura, and he held it in his hand like this, and he said, "But it is so strange. It is calcite." And I said, "But that's normal. He only works in rubber, because in Europe all the fossils are preserved like that." But because this is a moldic fossil, and because you break it and have part and counterpart, look what you get. This is the exact same specimen on the inside. See that? It's like you prep the specimen out, and you can see the outside and the inside. And what the inside shows is absolutely bizarre. These are the floor plates. The cover plates are stripped out. They're not biserial, they're quadriserial. See, there's outside, inside, inside, outside. And here, that's on the top of the animal, and if you look at it from the inside, you see there's an outside row, inside row, inside row, outside row. There's 4 rows of plates. Not 2, 4. And the pores are also arranged in 4 rows. There's an outside row here, an inside row, an inside row, and an outside row. There's 4 rows of pores. This is weird. Again, trust me, it's weird. It looks like that. That is not like any echinoderm known, but maybe not. We'll get to that near the end. And in cross-section, it looks like this. Here's the inner pair of plates, the outer pair of plates, and then the cover plates articulate in a notch halfway across. Very odd. This suggests there may be a fundamentally different way to explain Edrioasteroid evolution. What I think this is pointing to is perhaps primitively Edrioasteroids had 2 sets of floor plates, a row on the inside, or paired row on the inside, paired row on the outside. But different groups of these Edrioasteroids differentiated themselves by reducing or changing the expression of these 4 rows of plates. And what we're seeing is the change in the floor plate expression is changing the way they appear on the outside as well. Now what I'm going to do is review a couple other taxons, see what we can see, and see if this 4 rows of plates model makes sense. I'm going to look at a couple of things, a thing called Cambraster. It's Cambrian, believe it or not. And a strange thing I should have called, in Stromatocystis, these are similar things. There's this mysterious Stromatocystis described by Andrew Smith that is very funny. Walcotty discus from the Burgess Shale. And then we're going to look at a few other types of Edrioasteroids of the more normal type and see if we can see the same sort of things. Here's Cambraster. About all you can say for Cambraster is I fundamentally don't understand this animal. It's very poorly preserved. You get the gist of it, though. There's ambulacra and so on. It's also unusual because it's plated across the bottom. Okay? So if you flip it over, you can't actually see the floor plates, which also makes it very difficult to interpret in this particular sense. Problematic. This is the mystery Stromatocystis that Andrew Smith described. Stromatocystis is plated across the bottom. This specimen is not. Now, when I look at this specimen, I see something very cool. Look. See it? There's our 2 rows of plates on the inside. If you look really closely, there's the rows on the outside. This thing has the same 4 sets of rows of plates that we saw in the thing from China. Okay? So this had already been illustrated in the literature, it just wasn't recognized for what it was. And it is also not Stromatocysteides. This is the same basic taxon as we have from China. It looks like that. Same basic cross-sectional distribution. Here's Walcott's discus. If you've ever seen a bad edria, or if you ever want to see one, look at this thing. This, although it's from the Burgess Shale, everyone loves the Burgess Shale, this thing is split right through the middle. It is terrible. You can't see anything. But if you have a trained eye and the right lighting, there's a few things you can make out. This is an ambulacrum, believe it or not. There are the plates being exposed on the outside, the floor plates, okay? So it has those externally exposed floor plates, and if you squint real hard and look at a different ambulacrum, see them? There's those same U's. You see the pores? Out, in, out, in, out, in. Same thing. 4 rows of floor plates, just like we already saw. Woohoo! Life is good. That's the good specimen of Walcott's discus. Here's the other one. Yikes. But again, with a trained eye, that's one, there's a counterpart, and so on. It's the same thing. Now the thing that's also interesting and hasn't been recognized in Walcott's discus, it's often been described as being a biscuit-shaped thing. That is a folded over peripheral rim. Okay? It's actually shaped a bit like Isoropus, but pumped up, just like our friend from China is. In fact, here's one of the ones from China, preserved on the inside, and there's the peripheral rim folded over, just like that specimen of Walcott's discus is. Obviously, the one from China is much better preserved. The way you could fix Walcott's discus, the curator there wouldn't let me do, and that's soak it in a bucket of acid overnight. They kind of frowned on my suggestion, but it would have helped a lot. But there's Walcott's discus, same construction. Okay? So, I think I've established now that the primitive condition in Edrioasteroids is not a biserial set of plates with cover plates. It is a quadriserial arrangement with cover plates. Okay, now let's start looking at some less exotic Edrios. Now you've never seen one of these in Cincinnati, but you've seen things very similar to this, believe it or not. This is called a pergocystid. They kind of extend up a little bit. They're little discs, but they extend up a little bit. And the most recent work on pergocystids was done by Gunsberg and Sprinkle. They discovered that there's an extra set of plates here that they call hood plates. So here are the cover plates right here. Those are cover plates. And you see these extra row of plates here? Those were what they call hood plates. They reconstructed it like this. Okay? Cover plates here, hood plates here. And then they went on to make the most outlandish statement I've ever heard. There are no floor plates in pergocystids. In other words, the animal would open up its cover plates but not have anything to transfer the food to the mouth. Now this makes a whole lot of sense to me. I don't know about you. That was a joke. So they reconstructed it like this. See, here's our big cover plates here, but there's no food group. So there's no way to transfer food to the mouth because the floor plate should be here. There's obviously these hood plates there. There's no problem with that. And there are a few echinoderms that do lack floor plates. Not a single one of them is an Edrioasteroid. All of the ones that lack floor plates also have something else in common. They all have a food group. Probably the most classic example would be something like Pentramites. The food group runs along plates that have nothing to do with the ambulacral system for most of their length. Okay? So it is possible. And then we have some more rubber fossils. These are rubber fossils from Morocco. The new pergocystid. And that's the inside of a pergocystid. And the first thing I did when I saw this, I looked at my Spanish colleague and said, floor plates. Duh. Now, if you didn't have the inside, you couldn't actually see what was going on. And then the next thing that hit my head was even more bizarre. Floor plates, and so those should be cover plates, but look what's on top of the cover plates. Cover plates. Okay, that's weird.